All right, guys, here we go. The Now that we've talked about like the terminology and stuff, I'm gonna get into the big principles of experimental design. In an experiment, random assignment is really important. I mean, I can't say which one's more important than the other ones, but you've seen it with the dot plot we did with picking word length for the that paragraph from the articles of, I forget what those articles are called. You guys probably know. You guys saw that when we did this with human chance or human random, we went way too high, right? In an experiment, if you go with random assignment, it means that experimental units are assigned to treatments using a chance process. It guarantees that we get actual random behavior as opposed to what we think we're doing in our head. We do this to ensure that experimental groups end up being as similar as possible. Now, how does using a random chance behavior ensure that they're as similar as possible? What it should do is it should evenly distribute any lurking variables. That's what should happen. It should evenly distribute any lurking variables, even if we're not aware that they exist. Okay, I'm going to have you read the book example on 251 on your own. It's important to read it. This example gives you different chance devices, and you're going to be asked to say how you would use different chance devices to separate your group. So you should read that. But I'm going to move on here. Principle of experimental design number 2 and 3. In an experiment, control means that we keep other variables constant. Like you get a placebo, but as far as the active ingredient, we're keeping you constant the way that you were so we can see if the difference is because of the medicine. It keeps other variables constant for all experimental units. We do this so we can compare results from different treatment groups. Okay, if I read page 252 following the cola experiment, I still think you should go read that, but do it on your own time here. Reading this, random assignment distributes students who regularly consume caffeine in roughly equal numbers. So in that group of subjects, some students regularly drink caffeine, some of them don't. And so when you randomly assign them, they go to both spots. So you won't have a lurking variable making one group heavy with caffeine usage. It also balances out students with high metabolism and those with larger body sizes. So there could be lots of lurking variables in your group of people in your sample. So how can you make sure that lurking variable doesn't get into your study? Use random assignment so it evenly distributes them. It'll do a better job than you will. Because, let me say one more time, we suck at random. Okay, principle of experiment design number 4. In an experiment, replication means using enough experimental units to distinguish a difference. To distinguish a difference in the effects of the treatments from chance, variation, due to random assignment. Okay. Read that again. I'm going to sit back and let you read. Go ahead, read that again. So what I mean here is I take a large sample size, take a whole bunch of people, because when I use chance to put them in the two groups, if I have a large group of subjects, that really gives the opportunity for chance to even out the lurking variables and put them in both places. If you have a small group of subjects, it's possible that chance doesn't get it right and you get lurking variable heavy on one group and non-lurking variable on the other group, and your results are worthless. But if you take a whole bunch of subjects and you use chance, it will even out. So if you see a difference in the two groups, it's gotta be because of the treatment, not because of the fact that chance didn't play out and you got a lurking variable heavy group. In statistics, replication means use enough subjects so that your chance process can even out your two groups. All right, summing up the 4 principles. Comparison. I want to use a design that allows us to compare different treatment groups. I always want to do that. It's not worth doing an experiment if you don't have something to compare to. Random assignment. We always want to let chance do the work to assign experimental units to treatments, because we try to be random and we suck at it. Doing so helps us create roughly equivalent, it's not perfect, but roughly equivalent groups by balancing the effects of other variables into the groups. Lurking variables just get put in both groups, so other than the treatment, the groups should be the same if we use random assignment paired with replication so that we have lots of people in our groups. So turn the page one more time. And here we go. Control. We have to keep other variables the same for all treatment groups, especially variables that could likely have an effect on the response variable. So in doing so, we're limiting some of the experience from becoming a lurking variable. If we keep everything else the same, it's got to be because of our actual treatment. Controlling other variables lessens those variables' ability as a lurking variable to create a confounding situation. And controlling the other variables helps to reduce variation in the response variable. If they all, if they're taking pills and they're taking placebos, they both react similarly. So it reduces variation from lurking variables and kind of ensures that if there's variation, it's got to be because of the treatment. And then finally, replication is a big one. Use enough experimental units in each treatment group so that any differences you see in the effects of treatments, they can be distinguished from differences in other variables like lurking variables in the groups due to the chance assignment. Okay, so what I'm saying is if you have a small amount of experimental units, then when you use chance, you're still playing the risk that you might get a lurking variable heavy group. And so your numbers will be off. But if you'd use a big number of subjects, chance works out in the end. It's something that really, after you take more and more and more subjects, it really does even things out. Okay, so I'm going to have you read this book example on the Physician's Health Study, and then go do both check your understandings. I will do them as well. I'll come back and we'll go over the responses.